Okay, everybody. This is section 9.2, and it is called special right triangles. I don't particularly like the name, but there are two of them. And boy, are they ever used a lot. And your first exposure to them, some people have real trouble with them. You have to deal with radicals. That means square roots and stuff like that. I'm going to show you where these ideas come from, and then we're going to practice, practice, practice. And it's even then doesn't become very easy to most people. But it's essential that you get this stuff down if you're ever going to take the actual class called trigonometry. They depend on these special right triangles a lot. Just a quick note. When I went to college, and I know I'm really old, but when I went to college, um, I took a class called technical drawing. And when you went to the bookstore to buy the materials, you would have to buy a book, but you also had to buy a drawing kit. And the drawing kit included two 30, 60, 90, no, a 30, 60, 90 right triangle and a 45, 45, 90 right triangle. And the reason why is because those angles, 30, 60, 45, and 90s, are used so often in the construction of and development of, making plans for making just about anything. Those triangles show up so often that you'd have to buy special plastic triangles that had those angles already in them so you wouldn't have to measure them when you needed them because they were needed so often. Anyway, here comes the discussion. The first one we're going to talk about is a 45, 45, 90. And the 45, 45, 90 comes from a very important thing in our existence, the square. And the square has all four sides the same, as you know, and all four angles are right angles. It is also a rhombus. It's also a rectangle. You learned that prior to this. If you were to, I'm going to do it this way. If you were to cut it off like this with a diagonal through it, and you wanted to look at just one of these triangles, so I'm going to remind us where it came from, but I'm going to erase this, try to get you to think of just the one that's still solid. This one right down here came from a square, so we know that this is a right angle. We know that these two sides are the same length. We also know that this hypotenuse, which is what this diagonal is to that square, is longer than either of these two. So it's not x, so I'm going to call it y for right now. And then I'm going to use Pythagorean theorem to try to figure out what y is in terms of x. And I know that's still an enigma to a lot of you, but this is what Pythagorean theorem would tell us on this. My objective, after I write it, my objective is to solve for y. So watch what happens. I get x squared plus x squared, those are the two legs, equals the hypotenuse squared, y squared. I'm trying to solve for y. You might think, well, just square root both sides. Not yet. I want to combine like terms. That's going to be 2x squared, because I got one of them here and one of them here. That's two of them when I combine like terms. And then to solve for y, I'm going to square root both sides. So if I square root this and square root this, here's what I get. I get y over here. And then you have to remember about simplifying radicals. Anytime there's a pair of things, one gets to come out. In other words, the square root of that x squared, that's just x. But the 2 is not a perfect square, so he has to stay inside. And so y is equal to x root 2. So I'm going to come up here, and instead of writing y, I'm going to write x root 2. And that is the relationship for this special right triangle. By the way, when I drew that, because it's a rhombus, it split the angles in half that it came from. So this is 45 degrees. This is 45 degrees. And just another reminder, since these two angles are the same, we could call those base angles. The legs opposite them are the same size. Besides that, it came from a square. And this is longer than that. The square root of 2, by the way, is about 1.41. It's not quite 1.5. So this is longer, but not quite 1.5 times longer. It's irrational. It's 1.41 about. But none of that is either here nor there what you have to do. If you're given a right triangle, and they tell you it's a 45, 45, 90, for example, they might tell you that this is 3 and this is 3. Find this. Well, knowing that this is 3 and this is 3 and this is a right angle tells you you have a 45, 45, 90 because it's isosceles. And since you know the lengths of both legs, the hypotenuse is going to be one of those legs, it doesn't matter which one, times the square root of 2. That's the length. That's what the question mark is, 3 root 2. So that one wasn't very hard. When it gets tough, it gets tough when you do stuff like this. If I tell you, for example, that this hypotenuse is 10, find the lengths of the legs. They're going to be the same length because it's a 45, 45, 90. But what the heck are they? Well, here's what you have to know. This is the kind of thinking you have to do. It's inverse thinking. If over here you took the length of a leg, 3, and multiplied it by root 2 to get the length of the hypotenuse. Then if you have the length of the hypotenuse, you have to divide by root 2 to get back to the length. So whatever this is, you divide it by root 2, and that gives you the lengths of the legs. Now, I personally will let you leave it like this. The author will not. He wants you to rationalize the denominator. So here's another math skill that you have to have. If the leg is 10 over root 2, you have to remember from Algebra 1 that if you want to rationalize this denominator, in other words, get rid of that radical in the denominator, we have to multiply by 1. And you're going, that's not 1. Yes, it is. Square root of 2 over the square root of 2. Why did I choose that? Because root 2 times root 2 is 2. It's the square root of 4, which is 2. On the top, I have 10 root 2. Ten times root 2, they don't multiply, so it's just 10 root 2. On the bottom, I have root 2 times root 2, which is 2, and the radical's gone. Hallelujah. But I still have one more thing to do, and that's reduce this fraction, because 10 and 2 have a common factor, which is 2. So the answer is 5 root 2. So these guys right here, which I will allow you to leave like this if you want. The book, if you're going to go check your work, the book will tell you that's got to be 5 root 2. So if you have the hypotenuse and you want to get back to a leg, you got to divide by root 2. If you have a leg and you want to get to the hypotenuse, you multiply by root 2 in a 45, 45, 90. Okay, let's take a look at 30, 60, 90s. 30, 60, 90s also come from a very familiar shape called an equilateral triangle. So if I have an equilateral triangle here, and it's not a really great drawing, this is a little bit too far out. Hang on a minute, I'm going to fix it. Okay, if I have an equilateral triangle so that all sides are the same length, for reasons of avoiding fractions, I'm going to call this 2x, and this 2x, and this 2x. And then what I'm going to do, kind of like I did with the diagonal up here, I drew a diagonal to cut it off so I could get a triangle. I'm going to drop an altitude. I'm going to drop this down here. And because it's an equilateral triangle, 3 things happen. I cut this angle in half when I drop it. I'm perpendicular to the opposite side, and I cut this side in half. It's really cool how that works. Those are properties that we established in prior chapters and sections. So if that happened, then this length right here is now not 2x, but x. This length, oh, by the way, I'm going to erase this one over here so that you focus on the one that I got left. I want to look at this triangle right here. This is x because it used to be 2x, and we cut it in half with the altitude. This used to be a 60-degree angle because equilateral triangles have 60, 60, 60. I cut that in half. Now I've got a 30. This is still 60. But what the heck is this? Kind of like up here, I wondered, what the heck is that? I put a y on it. I had no idea what it was. So I'm going to use Pythagorean theorem again. So watch this. This is going to be, if I'm looking at this triangle right here, and I've got all these suppositions, this 30 here, this 60 here, right angle here, x here, 2x there. Pythagorean theorem says that y squared plus x squared equals all of 2x squared. Yeah, it's important that you square the whole thing. Again, my objective is to solve for y. I'll clean things up just a little bit. This one takes a little longer. When I square that, I square the 2 and the x, and I get 4x squared. Then I'm going to subtract x squared from both sides, and I get, because I'm trying to solve for y, so I'm going to get rid of that x squared by subtraction. I get 3x squared. And then I'm going to square root to solve for y, and I get y equals, in the square root, I get, for the same reason I did up above, I'm going to get x root 3. Because there was a pair of x's, one gets to come out. Since there was not a pair of 3's, the 3 has to stay inside. So this guy right here isn't going to be y anymore. It's going to be related to x. It's going to be x root 3. So this is some application of that. If you have, oh, I guess I better show you a couple of relationships first. In a 30, 60, 90, the 30 is opposite the shortest side. The right angle is opposite the longest side, as always. Sorry about that stupid bell. And so the shortest side and the longest side are in a ratio of 2 to 1. Whatever the short side is, twice that's going to be the long side, which is always the hypotenuse. So the short side and the hypotenuse are in a ratio of 2 to 1. It's this weirdo here, this middle-sized side, the other leg, the long leg. That's going to be the short side times the square root of 2. I'm sorry, times the square root of 3. So if I tell you that this is 4, you can be sure that if this is a 30/60, I better write that in there. If this short leg is 4, then you can be sure that this hypotenuse is 8, 2 to 1. And you can also be sure that this long leg is 4 root 3. Whatever the short leg is, whatever this is, x right here, times the square root of 3 is the long leg. So this one's 4 root 3. And so it's pretty easy if they give you the short leg. It's even pretty easy if they give you the hypotenuse, like this. So they tell you this is a 30, 60, 90. Here's the 30, 60, 90. If I tell you that the hypotenuse is 10, then you can be sure that the short leg is 5, 2 to 1 on the short and the longest part. Hypotenuse here, 2 to 1. Then whatever the short leg is times the square root of 3 is this one. One thing you can't do, that I suggest you try not to do anyway, you can't go from the hypotenuse to the long leg. If the short leg is not known, if this is not what's given to you, get to there first. Always find the short leg first, because everything is written in terms of it. It is x. Okay, so what I did is first of all, even if they say find this, and this is the only x there, find this first and then root 3 it to get that. So you don't want to go from here to here. That's a tough thing to do. So let's see what happens if I give you the long leg. Let's say that I tell you there's a 30, 60, 90, and I tell you that this long leg over here is 8. Find this. Don't go from here to here. Go from here to here. The short leg is what you always want to find if it's not handed to you. But how do you get from the long leg to the short leg? Well, remember what we did up here? If I had the hypotenuse, we divided by root 2 to get back to a leg. So if I've got the long leg, I divide by root 3 to get back to the short leg. If the short leg is 8 divided by root 3, then twice that is this that I'm looking for, and that's going to be, well, I'll show you. It's going to be 8 over root 3 times 2. We're going to double it, and that 2 is over 1, so it's going to be 16 over root 3. And I'll let you get away with this, leaving the root 3 in the bottom. However, the author of the book will not. And so if you have to take that 8 root 3 and rationalize the denominator to answer this question, you would multiply. No, sorry. Try that again. You take the 8 over the root 3, and you multiply by root 3 over root 3 this time, because that product will have a 3 in the bottom. Since root 3 times root 3 is root 9. Can you still see what I'm doing? Yeah. Okay. So root 3 times root 3 is root 9, but the square root of 9 is 3. So that took the radical off the denominator. That's great. So what I have is 8 root 3 up here. Now before, when I had that, I had 10 root 2 over 2. Can you still see that? 10 root 2 over 2. The 10 and the 2 had a common factor. Down here, 8 and 3 don't. So I'm leaving it. That's as good as it gets. So 8 over root 3 is the same thing as 8 root 3 over 3. And if you double that, the 8 and the 2 multiply, and you get 16 root 3 over 3, which is a lot of arithmetic there. So this is the same thing as 16 root 3 over 3. The author will give you these. I will let you get away with these as your teacher. Okay? So if you have to rationalize the denominator for whoever, this is how you go about it. But if you're doing it for me, you can just leave the radical in the denominator. But I went from here to here by dividing by root 3. Since if I was going from here to here, I would multiply by root 3. So I'm going back, I divide by root 3, and then I double that. It doubles the numerator. Okay, that's the lecture. Now let's practice some. Let's go ahead and do example 1. Example 1 is on page, let me see if I can straighten this out for you. Not this way. Okay. Example 1 is, it says to find x, and this is the information that you get. If this is 45, that's got to be 45. For 45, 45, 90ing, and this is the legs. So I have a leg of 8, means this is 8. If I want to find this, it would be 8 root 2, because I got to multiply the leg times root 2 to get to the hypotenuse, and that is what they wanted us to find. The other part of that example has another triangle drawn like this. It's got an x and an x and a 5 root 2. Okay, so since this is the same as this, the legs are the same, we know we've got a 45 without them telling us that. 45, 45, 90. And what they gave us was the hypotenuse. How do I get back to a leg? I divide by root 2. I take whatever the hypotenuse is, and I divide it by root 2. Oh, and look at that. Isn't that nice? Those cancel clear out. And so x equals 5 in both cases. So that one was nice. Both cases because they're both x. So that was example 1. Let's try example 2. It says, got a triangle like this. 30, 60, they tell you that, and they put the 90 there. They also tell you that this is 9, and this is x, and this is y. And they want you to find x and y. This is the long leg. Crap, it's one of those, got the long leg. But if you have the long leg and you want to go to the short leg, which you surely do, you always want to go to the short leg. To get from the long leg to the short, you take the long leg and divide it by root 3. So x is equal to 9 over root 3, which will be perfectly fine for me. However, 9 divided by root 3 rationalized for the author would be 9 times root 3. That doesn't fix itself. But root 3 times root 3 is 3. Oh, and look, the 9 and the 3 have got something in common. So the answer is 3 root 3. So I will accept 9 divided by root 3, but the author wants you to write it 3 root 3. If you double either one of those, because you got the short leg, if you double either one of those to get to the y, if you double this one, you double the numerator. So y is equal to 18 over root 3, which is fine for me. If you double this one, you get 6 root 3. So unrationalized denominator is fine. When you double it, you double the numerator. So this is fine. This is fine for me. This is what the author will expect, just in case you want to check your answer. Okay. Example 3 says, the road sign, it's a yield sign. It looks like this. It says yield in the middle of it. And it's got the border on it, all that stuff. Anyway, it says, the road sign is shaped like an equilateral triangle. Estimate the area of the sign by finding the area of the equilateral triangle. So this is 36 inches here. It's 3 feet. That's a big sign. I almost put foot. So this is 36 inches, and we want to find the area of this triangle. Well, the area of a triangle, when we find it directly, is 1/2 the base times the height. And bases and heights have to be perpendicular to each other. So I'm going to take this off of here so that we can make a drawing. This is part of the yield sign, but I'm going to take it off because I want you to focus on just the triangle. If you're going to let this be the base, then this has to be the height. So if this is equal to b, then this has to be h. So far, this is what I know. 1/2 of 36 times what? What am I going to multiply by here? It's got to be the length of this. Oh, but when I did this, I created a 30, 60, 90. Cut this side in half, making this 18. This length from here to here is 18 inches. And it's the short side. So the short side times root 3 is the long side, which is what I need. This is 18 root 3. So I put that here. And it said to estimate, and the reason why they said estimate is because we're dealing with an irrational number, that root 3. But again, this problem's got context. You don't go to somebody and tell them, I need a sign that is 1/2 by 36 by 18 root 3. I mean, who has an area that's that product? That's ridiculous. So in the calculator, we put it up here like this. We take 1/2, I'm going to use 0.5, times 36, close it, open another parenthesis, 18, and just snug it right up against the square root of 3, just like that. And when I get that done, it will give me an answer as exact as it can, but I close that parenthesis around there. Oh, I don't need that one. Sorry. I don't need this one. That's going to cause me problems. Like that. Okay? If I hit enter now, it will tell me the area of that, but it's irrational. Extra long decimal back here and all the crap that goes with it. That's really, really long. You don't go to somebody and say, yep, that sign's going to be 561.1844617, although that is much better than saying that sign is whatever 1/2 would be 18 times 324 root 3. You don't say that because this problem has context. So you would say 561.2, I would say. So the area is approximately 561.2 inches square. Okay, last one, example 4. It says a tipping platform. It's kind of weird. It kind of looks like this if you're not looking. It's on page 474 if you want to look. It's called a tipping ramp, and they take a truck and they put it flat on the ramp. Well, they put it flat on the ground that's on the ramp, and then they raise this ramp up like this. They raise it from here, and they go like this. And they raise it up like this, and the truck's sitting on it like this. Here's your truck. I'm not very good drawing at this, but the truck comes up like this, and here's his trailer back here, and it sits on there like that. And the truck, and we got the wheels here, here. Okay, so there's your truck. It sits up like that, and they do it to unload it. If you got a big old thing and it doesn't matter, whatever you got in there is gravel. It won't be gravel, but sawdust or something like that to maybe put on a playground or something like that. It's just full of a whole bunch of stuff, and you want to dump it out. They put you on this ramp, and they raise it up like that until all the stuff falls out the back. That's neither here nor there to doing the math. But it says, a tipping platform is a ramp used to unload trucks. How high is the end of an 80-foot ramp? So the 80 goes here. That's an 80-foot ramp. When the tipping angle is 30 degrees, we want to know how high this end is. How high did it come up off the ground? So that's our x. If this is 30 degrees, then what I have is a hypotenuse in a 30, 60, 90, a hypotenuse that's 80, and I want the short leg because it's opposite the 30-degree angle, so it's 40. So the answer would be 40 feet. That's ridiculous. That's 4 stories high. That is a heck of a tipping ramp. It's going to get even worse because what they're saying now is what would happen if your tipping ramp made an angle of 45 degrees. So this is 80. How high is this? We want to know that distance. If this is 80 right here in a 45, 45, 90, then I've got the hypotenuse, and I want to get back to a leg. How do I do that? I divide 80, whoops, sorry about that, 80, the hypotenuse, divided by the square root of 2. And because this problem has context to it, I don't want to rationalize that denominator or answer it with a radical in it. I want to figure out what it is. So I go 80 divided by the square root of 2, like that. And I get 56.57 or 56.6, approximately equal to 56.6 feet. If the tipping angle was 45 degrees, it would be 40 feet if the tipping angle was 30 degrees. So that's a couple of problems with context to it that you can take a look at. That was example 4, and that is it. So the assignment, if you are doing it in my class in school, is section 9.2, numbers 1 through 17 and 20. So 18 problems. Okay, there you go on special right triangles. Good luck. Let me know if I can help.